So I'm going to be talking about the Marlowe command line tool. I'll give you a brief overview and also a brief tutorial. The tool called Marlowe CLI is made to enable developers to submit transactions and interact with Marlowe contracts from the command line and do that on the live blockchain, so on one of the test nets, for example. Some of you may be familiar with the Cardano-CLI tool, which folks have used to submit transactions, whether plain ones, simple scripts, or Plutus scripts on the blockchain. Marlowe takes that a step further and lets you submit Marlowe contracts on the blockchain. So there's several use cases, and we're just outlining a couple of them here. This is not an exclusive list, but gives you an idea of the things that you might be able to do with the Marlowe CLI tool. First, it facilitates interaction and development of Marlowe contracts. So you can do things like measure the transaction size, submit transactions to the blockchain, test your integration with wallets, or debug validators. So this is a developer tool. It's a number of different modes we'll talk about, but it's for getting into the nitty-gritty of operating Marlowe contracts. It also gives you early access to Marlowe capabilities on testnet or even mainnet. So you can run Marlowe contracts. You don't need a web browser. You don't need a phone. You can create your own workflow that operates Marlowe. A third use case is to integrate with your own workflow or tool set. So you can wrap the Marlowe CLI tool in the way that folks have wrapped Cardano CLI to create services such as libraries, faucets, marketplaces, things like that. And then, of course, it can be used for training in the use of Marlowe, so people can get a deeper understanding of how Marlowe transactions actually work. The Marlowe Run user interface provides an abstract view of those transactions. Marlowe CLI provides a very concrete representation of them that's quite close to what's occurring on chain. So we have several ways we can use Marlowe CLI to interact on the blockchain. I'm going to mostly focus on the high-level method listed here, but we also have two others. The high-level method is really for supporting workflows where you just want to run a contract at the command line. It hides some of the details of Plutus and Cardano nodes and the internals of how input and state work in Marlowe contracts. So it really focuses just on the contract. You can also run this Marlowe CLI to operate the Plutus application backend for Marlowe. So there you're directly interacting with the Plutus application backend, which actually has 3 contracts for Marlowe and several endpoints, and you can interact that way. This lets you operate at an even higher level. You don't have to do TXO management and things like that. You're actually letting either Cardano wallet or Daedalus do that wallet and UTXO work in the contract operation. So this actually very closely mimics the workflow of Marlowe Run, because Marlowe Run is actually using the Plutus application backend. There's also a low-level mode that is really for developers that are mostly debugging or really want like fine-grained control over each little operation involved in running a Marlowe contract. So you can control and modify the Marlowe state, construct input, look at information about the validators, datums, and redeemers, and basically all the Plutus stuff that's under the hood when you're running a smart contract like Marlowe. This is simple to interact with. It basically installs the way you would install any tool in the Cardano ecosystem. You have, one option, which is to use Nix. So if you're using a Nix-based system and you have Cabal installed there, you just clone the repository, open a shell, and install the tool. Or if you're not using Nix or NixOS and you have the Cabal and GHC tool chains already installed on your machine, you just clone the repository and install Marlowe CLI. It will take a little while if you haven't been doing Cardano development for all the dependencies to download and various packages to build. But with a little patience, you'll have a working version of Marlowe CLI after doing the simple installation. So the basic interface for a command line tool is the command line. So here's an example of just listing all the tools that are available within Marlowe CLI. And we're not going to go over all these, but I pointed out we have both these high-level and low-level commands. We'll be focusing on the high-level commands today. And the high-level workflow actually builds on those commands. It's basically built around user interaction. So you might, in Marlowe Playground, either type or graphically design a contract, maybe using block-cli or using Haskell, and then export that from the playground, and then you have a contract and you want to run it on the network. So using Marlowe CLI, you actually have that JSON file that's coming out of Marlowe Playground, and you have various operations you can use to make the contract operate. So the first step here at the top, this top circle, the user needs to decide on which contract they're going to run and its parameters. If it's a template that's already built into Marlowe CLI, it's really simple. You can just create that JSON file. If you're not using a template, you have to download it from the Marlowe Playground. And then you initialize the contract. And this is basically just bundling information together about which contract you're running, its initial state, who are the people, what are the addresses involved in the contract. So all that sort of upfront work. And then we basically have a execute command that actually submits the first transaction of the contract onto the blockchain. And then once you've done that, that execution might actually send out some payments. It might just be a single execution where you finished the contract. Or if the contract is not complete, then the user gets to decide what the next input is for the contract. After they've made that decision, they prepare the next step of the contract, and then they execute it. So what you'll see in the example is that once we've done this preliminary work, you're basically doing execute, prepare, and then execute. And you just kind of keep going in that circle to advance the contract. This is actually what you'd see visually if you're using Marlowe Run. You'd see cards that show the contract progressing. So this is mimicking that process. So I mentioned we have some templates. Just to get folks started, we have 4 templates that are available in the playground and in other Marlowe literature. You may be familiar with the escrow contract. There's a very simple contract just to get started with, and then a swap and a zero coupon bond. So these are things you can experiment with at the command line on testnet. And then once you have your contract, either one of those, or as I mentioned, one you designed in the playground, there are just these couple commands for running the contract. I mentioned execute, which is actually putting the Marlowe transaction on the blockchain. Initialize is that preparatory transaction where you're taking your contract and kind of packaging all the information needed to run. And then before each step, you need to prepare the next set of input. And then to get funds outside of Marlowe, there's a withdraw function. So basically, these are the 4 functions one needs to use after you have a contract that may have come from the template or from the playground. I'll just briefly mention some of the low-level capabilities. This is really all I'm going to say about these today, but they let you do things like create Marlowe. So you actually can compute script addresses, validator hashes, datum hashes. You can look at the binary representation of the Plutus script. You can get JSON representations of the datum or the redeemer. You can count bytes, look at the execution cost and memory. And these things all matter if you're kind of in the nitty-gritty world of developing a contract. You want to know how much it's going to cost on the blockchain. You want to know if it's going to fit on the blockchain. You want maybe some, pre-computation of what these hashes are, things like that. And then that creation is supplemented by functions that actually build and submit transactions. Those low-level workflows actually come in 2 forms. So The first is what we're calling a monolithic workflow, where basically on the left here, you give it all the information about the contract. It bundles that all together, and we get what we call this Marlowe file. And then using query tools like JQ, which is a JSON query tool, you can pull out information about the contract. So this JSON file, this Marlowe file, is kind of a bundle of comprehensive information about the contract. And then if you want to go to submit transactions, you pull out what you need from it, and you can submit transactions here. You can actually submit them using Cardano CLI. You could submit them, using Frost or some web service for doing transaction submission. But all the Marlowe magic kind of occurs in this stage at the beginning. And then you're open to use all the data however you wish. There's a more granular workflow that really does the same thing, except you have individual commands for combining input data needed to run Marlowe into files or addresses, things like that. And then once again, you can run these with whatever tools you want to. So a little bit of background of just basically how Marlowe uses Plutus in the Cardano ecosystem. So Marlowe is a Plutus script, so it's a validator. And there's actually one Marlowe validator for all Marlowe contracts. So it's basically an interpreter. It's a generic script that can run any Marlowe contract. When the contract is created, this is slightly specialized for things like the particular network, if you're running on a public or private testnet or on mainnet, and what's the currency symbol for the roles involved in the script. So there's a tiny bit of specialization, but it's basically a generic validator. And in the Plutus world, datum is attached to a UTXO. That datum basically gives state information about that UTXO. It restricts how it can be spent. And in the Marlowe world, the datum basically contains the part of the actual contract that needs to be executed still. So as you're executing a Marlowe contract on chain, the datum, or the contract part of the datum, will get smaller and smaller because there's less and less to do in the future. The datum also contains this information of the contract, which has things like balances, a record of the past inputs, any values or parameters in the contract. So you can really think of datum as the state needed to move the contract forward. The redeemer in the Plutus world is what's given to a transaction in order to spend a UTXO that has the datum. So the redeemer in the Marlowe sense just has the input for the next step of the contract. So you're making a deposit, you're making a choice, you're making a notification. The redeemer would simply have that information. And then when the transaction is validated on chain, it's going to look at the datum, which is the current state, and it's going to look at the input, which is in the redeemer, and it's going to run the Plutus script, which is Marlowe, and decide whether that input was valid, and the contract can proceed to the next step. So I mentioned roles. Roles are very important in the Marlowe validator, and you should really be familiar with native tokens. They have a currency symbol, they have a token name, and Marlowe uses those. So each contract in Marlowe has a unique currency symbol, and associated with that currency symbol is what's called a validator script for making payments. So we have the main Marlowe script, and then we also have this subsidiary script just for doing payouts to pay to participants. And this is basically a design decision that was made for security around making payments and authenticating, ownership of the funds that will be dispersed. So the participants usually have a role token. This is not always the case. There's a way to use Marlowe contracts without role tokens, but the standard use case uses role tokens. And they're basically just a native token, a Cardano native token, that uses the currency symbol for the contract, and the token name is the name of the participant. And you'll see how this works later on. The participants, as I mentioned, are withdrawing funds from this payout script, and it enforces that the funds go to the correct person. So now we'll plunge into an example. I thought An escrow example might be a nice example of a high-level workflow. It involves 3 participants. We have a buyer that wishes to purchase an item. Let's say they're purchasing a bicycle or something. They're going to deposit funds. After they deposit funds and receive the item, they might say, hey, there's a problem with this. It didn't arrive, or it's not as advertised, or it doesn't work, or something like that. So they have that option. If they don't report a problem, then the funds just go to the seller. So that's kind of the standard use case. And we have a flowchart here where you have this deposit of funds. If when the buyer makes their decision, they say everything is all right, the seller receives their funds. So this is a simple path through the contract. But if they do report a problem, the seller might also agree that there's a problem, so there's no real dispute there, and buyer would just receive their refund. But the seller might also dispute that there is a problem. So if there's a dispute, then a third party comes in, the mediator, and they basically act as the judge and decide who actually was going to receive the funds. So those are the 3 roles. We have the decision about reporting a problem, where the buyer makes that decision. The seller gets to make a decision about whether or not to dispute if there is a problem, and then the mediator makes a decision about who's right. In addition to these decisions, the contract has what are called timeouts in it. So if one of the participants doesn't actually take the action they need to take, there's a default action that occurs in the contract. So, like if the buyer doesn't report a problem or say everything is all right, the contract just doesn't stop there. It actually waits and then it'll proceed. This is one of the features of Marlowe that prevents funds from getting locked in a contract forever. There's basically always a timeout in a contract. So if you built this contract in Blockly, this is what it would look like. We've kind of split the screen into 3 little slices because it's too long. The contract is too long to fit in a single screen and still be readable. But you can go look in Marlowe Playground. You can try building this yourself. We basically have this idea of the deposit, the decision here, whether everything is all right or reporting a problem, the next decision by the seller of either confirming or disputing the problem, and then a decision by the mediator, dismiss claim or confirm claim. There are various payouts here, depending on the logic in that flowchart. You can see these 2 different payouts. And then you'll also see there are some timeouts in the contract, these various deadlines that are over here on the side. So this is what the contract looks like in the Blockly world. We saw how it looks like as a flowchart. And in Marlowe format, which is basically a Haskell format, you could design the contract this way. In the Playground, you would see it as just plain text, but it's basically doing all the stuff we talked about before and presented as text. So I mentioned that we had these different paths through the contract. Here are 4 of the 8 ones. There are an additional 4 paths through the contract, 4 different outcomes more, which have to do with the timeouts, and I'm not going to go into that today. But the first one is the buyer says everything is all right. So we just walk through this path. Or the buyer can say that things are not all right, there's a problem, and the seller confirms the problem. So we go through this highlighted area. If the seller disputes, then it goes down to the mediator. And in the case where the mediator decides for the seller, we go down here, and the seller receives the funds that were deposited by the buyer. The last case here is where the mediator decides for the buyer, and the buyer gets a refund. So these are the cases. We're going to just look at one of these cases in more detail. So we have the 3 roles here. We've given them names, and we're going to look at the case where the seller receives the fund after there's a dispute and the mediator rules for the seller. So it's this path here. Buyer reports a problem, seller disputes, and the mediator dismisses the buyer's claim so that the funds go to the seller. So the first stage with Marlowe CLI is constructing the contract. So what you need is the names of the parties, you need the deadlines, you need the price of the item, and then there's a Cardano on-chain requirement for something called min ADA. And these are basically the input things. Here's what the contract looks like. Here's what the flowchart looks like. And we have these two validator scripts, these two addresses. One is for the contract, one is for the payout. And of course, initially they start empty. So we have the full contract, we have a bunch of input, and there's no funds in the contract. There are a lot of parameters here that we're going to be using. This is just for reference. You can refer to these later. We also have detailed tutorials online that go through all this information. This is what you'd actually do on the command line. It's a simple single command to create the escrow contract. You just say, we're going to use the template called escrow, and this is all the input we have to give it. We're going to give it a 3 ADA to start off the contract to hold at the script address. We're going to say the price is 256 ADA. We give the names of the seller, the buyer, and the mediator. We list these 4 deadlines that are in the contract. And then what this command line tool is going to give us is 2 things. It's going to give us the actual contract and the actual state. And these are both JSON files. So if you run this, you can look inside them and poke around and see what's in there. But basically, you're going to see the contract and you're going to see the initial state. The next step is to provide the min ADA and actually get the contract starter. So Christopher Marlowe, the mediator, is going to send 3 ADA to the script address to create the contract. So we're here on the flowchart. So at the contract address, we're going to have 3 ADA after this is run, and we're still going to have most of the contract to execute. Now, this is a little more complicated. This takes 2 commands, but we'll walk through them. As I mentioned earlier in the talk, first you have to initialize the contract, and then you're going to execute it. So initializing it, you tell it which network we're working on. This is the public test net that we're going to use, and a couple of network parameters. The tool understands the particular network you're working on. And then we mentioned earlier, there's a currency symbol for the roles. So you have to give it that currency symbol. And then you just give it the contract we produced from the template and the initial state we produced from the template. It'll take this information, package it all up together, and create this transaction1.marlowe file. So this is the comprehensive information that's needed to run that transaction. Once again, that's a JSON file, so you can open it up and take a look what's there. You'll see all the scripts and the validators and things. And then just to get more information, we're saying print stats. So we're going to get some statistical information about this transaction. So once you've bundled everything together for the transaction into this Marlowe file, then you can run it on the testnet. So we have to say a little bit about the testnet. Its network magic number, where the Cardano node is living on the socket path. And then we're going to be spending some ADA here. So we need to give it an input UTXO, some unspent transaction output that it can actually use to run the transaction. This is, as you remember, we'll be depositing 3 ADA. And then the mediator is going to get all the leftover ADA. The mediator has to sign the transaction. So they're a required signer. We're giving it this transaction1 Marlowe file that had all the information we bundled together. And we'll get a transaction. This is a standard transaction file for Marlowe. So you could actually submit this with Marlowe or Cardano CLI. You could submit it on Blockfrost. You could submit it with a wallet if you wanted, but the tool will submit it for you. So we say we do want to submit it, and we're going to wait up to 600 seconds for the transaction to be confirmed. So once you run this execute, you're going to probably wait 5 or 10 seconds. The transaction is confirmed, and then the transaction will actually be on the blockchain. The next step is depositing funds. So the buyer deposits the funds, 256 ADA to purchase the bicycle. So we've progressed here on the flowchart. According to the contract, which is in small print here, we've highlighted in red the remaining part of the contract. The part we just executed is up here where we're making the deposit. And that deposit actually goes into the account of the seller. So the buyer is depositing funds into the account of the seller. The contract is holding that, so the seller can't access those yet. The contract is protecting them, but Marlowe has a sense of accounts. So every bit of funding that's in the contract is assigned to one of the roles. So here we have kind of a similar pattern for creating and submitting a transaction. Instead of initialize, since this is a subsequent transaction, we're using the prepare command, and then once again, we use the execute command. And the prepare command basically just gives the contract input. So we had the state of the contract at transaction 1, this TX1 Marlowe file. After we've done the input, we're going to be ready for transaction 2. So we have tx2.marlowe. And this input is a deposit input. So we're depositing into the seller account. We are the buyer making the deposit. We're depositing 256 ADA, which is the price. And then we're going to tell the transaction that we don't want this transaction to be valid for any time. We're going to actually say it has to occur between this slot and this other slot on the blockchain. So this is sort of a standard thing when you're submitting Cardano transactions. Often you give a slot range where they're valid, and if it's just your deadline to submit the transaction. So that's basically the core of this, is we're just providing the input of the command line here. And a lot of the execute command is similar to what we saw before. We tell it about the network, we tell it the file, but this case, this is what we did at transaction 1. This is the input to the transaction. We give it the UTXO that's living on the Marlowe script, that's held in the script. So this is basically the result of transaction 1. And then because this is running a Plutus script, you have to give it collateral. So we choose a collateral UTXO, and then we actually have to deposit the ADA. So we need at least 256 ADA to make the deposit. And then the role token is held, in this case, by the buyer, because each participant, each role has its own role token. That role token is sitting in their wallet. You could look at it, and it basically is what authorizes the buyer to make a transaction. So they have to include the role token as input. They will get it back out. So the role token doesn't stay at the script, or it doesn't go anywhere, except it passes through the script and it comes back to the buyer so they can authorize another transaction. And then, of course, the buyer has to sign this, so they're a required signer. And then the transaction we're creating is this transaction 2.marlowe. So we're starting from transaction 1, we're going to transaction 2, and one of the outputs of this is just going to be, as I said, giving the buyer their token back, and then they get any leftover ADA as change. And there's a transaction file you could look at, and we submit it. So it sounds like a lot, but each piece has sort of a logical function. And as I mentioned before, we have a lot of tutorials that go through this step by step. So an example, we had this print statistics flag turned on. This are the sort of things that you will see when the statistics are printed. So here you can see that it was, first transaction was using about 0.19 ADA. That was the fee. The size of the transaction was 4% of the 16K limit on transaction size. So we're way under the transaction limit. And it actually wasn't running Plutus. So we didn't use any execution limit, execution steps, or memory. Transaction 2 was a Plutus transaction. So you can see it's quite a bit more expensive. It's 1.3 ADA. It was actually using 97% of the size, the budget for transactions. It was using a modest amount of memory and not a lot of computation, and 18% of the limit. And I should say that these limits have been raised recently. The memory limit in particular has been raised at recent epochs. So this is, these are real transactions. You can go into Cardano scan. You can watch the transactions occur, you can look at all the data that's going on. This is I believe, the second transaction. This is the Plutus one, so you can see the actual datum and redeemer and Plutus script on chain here. So back to our example, the buyer is now going to report there's a problem. So Thomas Middleton is saying, hey, there's a problem. I want my funds back. So what that does, we advance on this flow chart to this little diagram here. We're in this kind of arrow that says report problem. And what the contract actually does at the script address is it moves the funds from the seller's account into the buyer's account. Now, the buyer, once again, can't access these, but they are in his account. And the choice of which account the funds live in actually has to do with timeouts and contract design and things like that. So here you can see in gray, we've executed more of the contract. The red is what we have left to execute. And things get a little bit simpler here because a lot of this prepare and execute is kind of boilerplate. The only thing that really changes here from the second transaction is now we're not making a deposit, we're reporting a problem, which in the Marlowe world is called making a choice. So the choice is called report a problem. The party that's making the choice is the buyer, and then they're making choice number one. You could look in the contract and see that's the appropriate number to put there. And everything else is sort of the same. We have these restrictions on when the transaction can run. We have, here are the UTXOs that are being spent. We want our funds to come back to the buyer and things like that, and it gets submitted. So it's much simpler now. Transaction 4 is the seller disputing that there's a problem. So Francis Beaumont is making a choice here. So this is another decision diamond and another path through the contract. Their declaration that they're disputing, it doesn't actually change the disposition of funds in the contract. It's just notifying the contract to move along. So the contract sort of peels away more of itself, and you just have this little red part left. And the transaction is very similar to the third transaction. Here it's now the seller that's the party making the choice. They're making choice number 0, and they're just saying dispute problem. So because they're disputing, the mediator comes into the situation. So they have to make their decision. And in this case, they're deciding in favor of the seller. So Christopher Marlowe is saying, I'm dismissing the claim. The seller does get their funds. So what the contract does is the script does is it puts the funds back in the seller's account. And then it actually transfers the funds out of the Marlowe script into the payout script. So it's putting basically 256 ADA at the payout address. It's ready for the seller to collect it. And because the contract is over, it's taking the minimum ADA, and it's actually giving that back to Christopher Marlowe, who had supplied it when the contract was created. So we're basically moving things out of the contract here. And then there's essentially no contract left. There's just this little close statement that is the end of the contract. So this is another transaction reminiscent of numbers 3 and 4. Here we're saying dismiss claim. The mediators, the party that's making the choice, and they're choosing choice number 0 because that was the one that indicates they're dismissing the claim. So anyway, what we have here is the final sort of cleanup steps of running the contract. The seller is going to withdraw their funds. So they're pulling out their 256 ADA to their address. And this uses a different command in Marlowe CLI. This is the withdraw command. It's very similar to the other ones, but maybe a little bit simpler. You just, once again, tell it which network you're on, which transaction you're operating on, who you are. So the seller's withdrawing the funds. They're putting some UTXOs in. Most importantly, that they are identifying themselves with their role token, because that role token is kind of their passport or their identity that gives them authorization to do things with this script. And then we have collateral. They have to sign it. They're getting their role token back. They're getting their change. And they'll actually get their 256 ADA when all is said and done. Similarly, the mediator is withdrawing their 3 ADA. This is essentially an identical pattern for the transaction. So we had all these transactions. We had 7 transactions. Here's actually a map of the UTXOs involved in this. I know it's a little bit hard to read, but hopefully you can view it online at the Marlowe Cardano GitHub website, or just zoom in a little bit to these slides. But we have the participants here. They're each starting with a pair of UTXOs, one that has just ADA in it, and one that has their roll token in it. So the 3 folks are there. When Christopher Marlowe creates the first transaction, he's putting in ADA. It's creating the script. The script now has 3 ADA, and its accounts reflect that. He gets his change, and there's a 0.2 ADA fee. So the first transaction is kind of making this transition. The second transaction, Thomas Middleton is depositing his 256 ADA. He actually has a UTXO with almost 3,000 ADA. So he puts that in. He gets some change from that, about 200 or 2,700 ADA, and then his 256 ADA is in the script. He then reports a problem, which just updates the state of the script. So you can see the accounts have changed a little bit. It's paying a fee. Then Francis Beaumont, the seller, is disputing the problem. So he's passing his roll token and some ADA through the transaction. He's getting his roll token back. He's getting some change. We're paying a 1.3 ADA fee, and then the script state has been updated. And then when Christopher Marlowe dismisses the claim, he's putting some ADA in along with his roll token. We're consuming the script UTXO. And then this is an interesting transaction because it doesn't pay anything to the script because the script has done its job. We don't need any ADA there. It doesn't have any state. It's just closed. So it's actually, in that transaction, we're making 2 payments to the payout script. One is for Francis Beaumont, so he can get his 256 ADA back. The other is for Christopher Marlowe, who can get their 3 ADA back. So these are separate UTXOs. They're sitting at the payout script address. And then since Christopher Marlowe initiated this transaction, he's paying the fee and he's getting his roll token back and some change. So when he goes to withdraw his 3 ADA, he's using some of that same input, and then he gets back his ADA. So he ends up here with 3 unspent transaction outputs. Similarly, Francis Beaumont is getting his 256 ADA in transaction 6. So he's paying a little bit of a fee. He gets his ADA back. There's the 256, and then he gets his roll token. So this is kind of the big map of what's going on under the hood. So what Marlowe is doing is it validates all these transactions on chain. If you're running in Marlowe Run, it's hiding all this from you, and you get a nice graphical user interface, little cards that help you do the inputs. If you're running at Marlowe CLI, you have to type in the inputs, but you're driving this sort of workflow. At the beginning of the talk, I mentioned the lower level, more detailed interface. If you were doing that, you would still get the same transactions. So you actually see the same transactions, whether you're using Marlowe Run or the Plutus application backend, the workflow I showed you, or the low-level workflow. It's just you're interacting with it. You have a little more control. You get to see a little more of what is going on. So the Marlowe CLI tool is pretty much feature complete. So you can run these high-level workflows. You can interact with the Plutus application backend. You can do the low-level workflows. We're using this for testing, debugging, things like that. There are a few enhancements we'll be adding to it, something called Merkleization of contracts, which Marlowe supports, but the CLI does not support yet. It will help us reduce contract size. And then most of the other functions we plan to include are really convenience methods, so you can make some queries and do things like that. And this is all online and available to use on the testnet. So thank you.